Welcome again to another interesting um, day, another interesting video on OpenCV. We've done a lot. We've been looking at different simple projects and some not so simple projects in OpenCV, and we've done quite interesting ones. So I will advise you, if you've not watched this is the first videos we've watched, you should go back and you see a couple of more interesting videos and in the series. We've looked at um the basic functions that can be we are in OpenCV, the basic and important functionalities that we have in OpenCV, and we'll be using it to achieve a good number of tasks. For example, we've used it to carry out face detection, both we also use it to do attendance using um barcode, different projects, so many interesting projects. So I'll advise you to go back and look at them when you have time. But for now, today we'll be looking at another very interesting project. We'll be looking at intruder detection system using OpenCV. Of course, this is a very, very important project, especially now that security is getting worse and worse and worse. The beauty of this is that you may not need to buy such expensive devices um, for your houses any longer. You simply need to just design this and probably put in the phone or put in the PC and set it, and you can definitely watch it later. You understand? And or you can just develop it into a hardware, right? To your own tests, and then use it. So this will be done exclusively using using OpenCV. Will I say exclusively? Yes, exclusively using OpenCV. So how is it going to work? Now you can see this picture here, right? Um, that's we can see a door there. We can just, let's assume our security camera is there. So anytime anybody passes that door, it's going to notice that, oh, this person has passed through that door. That means somebody has entered this place, right? So it's more like a motion detector. Once it sees a motion around a particular spot, it may not be everywhere, around a particular spot, right? Probably the door, it knows that yes, this person is here, and then it is going to um, um focus on that, on whoever the intruder is. So that's basically what the project will be about. So how will it work? First of all, because this we can, of course, please, we can extend this to webcam, but for today we're using videos. In the previous videos we've seen a lot of, we've used webcam a lot, but we've not really used videos that are in our systems to local devices to carry out OpenCV operations on them. So today we'll be using videos, but it's the same thing. It's just basically, while the other one is videos, this one is returning what's from your webcam, right? Instead of saying the video here, you put probably 0 or 1 to tell you which camera you're using, but here you're going to put um the the address to the video. You see it when we start coding. So once you open the video, the very first frame we see, where of course will show us the entire room or entire block. We'll just pick where we want to really focus on, because let's assume we are on the road. We don't want, it's not everybody that passes the road that is an intruder. It's actually when somebody comes to your door that person is an intruder. So we will just pick that place. So you are the one that will decide where you want to really focus on. Then which is what we call the region of interest. That's where you're going to select ROI, region of interest. Then of course we initialize background subtractor. We will talk about that. Then we will loop over different frames, right? And then we will look up over each frame. Remember, videos are like pictures, different pictures that are in that come consecutively. So we'll go through all the frames in the videos. Then whenever it detects a motion, it will mark a bounding box around that place, and then it will display for us to see. Of course, once we see the bounding box, it's going to catch. We'll look at it again and see, oh, it's going to catch our attention, right? So that's just basically the idea to display. So this happens it happens regurgitatively until the end of the video. All right, so that's basically how
we are going to work on this. So let's quickly run into. I hope you understand. Please, if you don't, you can write on the comment box comment. But let's quickly run into our code. All right. So this is our Visual Studio Code. Again, we'll be using Visual Studio Code for our um, this project because it's easy, and I don't see why we should use something more complex because it works on Python, works on any other IDE, but Visual Studio Code for this one. It's basically the same thing. So I have a video here, which I just took myself. It's just me coming into a room, right? So this is the video. I think okay, let me just play that with right. So I'm the intruder in this case. So let's see if it's going to remember there are other things in this room. So it's not going to, it should not pick any other thing in this room. It should only pick the person coming in, which is the person that's the motion, no other static thing there should be picked. All right, so let's quickly let's create our Python file. So just call it main.py, and then we start coding. First of all, I'll import OS because I'm going to get something from my device. I just like doing that. It may not really be necessary, but let's just do that. And then import OpenCV CV2, which is OpenCV. Then something else we import is datetime, right? It's not really important. I may have to take it back because I don't think we'll ever use this. Let me just remove it because I'm not logging anything. If I'm logging, I will have used the datetime. Then import NumPy as NP, right? Because you're going to manipulate the images which will be in pixels, right? Okay, beautiful. So now let's get our video. So our video path is equal to tests.mp4. Test.mp4. Then of course you know how we get you can remember how we get our webcam. So it is this time around we're trying to get our video, but of course the same way we used to get our webcam. Cam is equal to cv2 dot the same way we used to get our webcam, right? But in case instead of 0 here we put video path. Beautiful. Then the next thing we do is, of course, this returns if we can catch anything, true or false. Then of course our frame will be equal to cap.read. All right. So now if this is just housekeeping, that if not return, right, or frame is none, right, what we to do is we just end it, and then we'll raise an error. Right, failed to open frame from the video. I don't even need this. Okay, Yeah, so that's fine. So all right, so now that we've gotten this, it has read it. Now we want to allow for selection. You should be able to select um which part of the frames, select which part of the frames I want to pick as the part is going to prioritize. That's a region of interest. But first of all, once it reads the frame, in case I don't select anything, it's going to take the whole frame as the region of interest. So let's just take that first. So let it take the whole frame at first, in case we have to close all the loopholes. All right. So 0 0 frame dot shape one. Right, the x and the y. So what the next thing we'll do is that we'll show the first frame, and then we'll now allow the user to select this his own, not our own any longer. So all right, when that happens, window, let's just call it window name. Let's just call it frame. What will come out? Just picture what will come out, right? Or I simply call it security system. You're asking, you may be wondering what this is. This is the window, what pops up. Remember when we are working on a video, that frame that pops up, we normally name it. So this time, this is what it's called, but it will be in a video form anyway. So we now show this cv2.imshow. Don't worry, we'll write where we need to pick them out. And we need to pick them out. So cv2.imshow, and that will be our window name. Just so I won't go back to this. Just get it out. It's going to put the frame there. Right, this frame. Okay. Next thing, remember when we drew over Macy's picture in one of our videos. So now we are going to draw over this video, right? So we have to use our mouse to draw. So you have to select the mouse click and then picture what happens during our mouse. So what happens during our mouse is this. Let me just go back to. So what happened with our mouse is this. Let's say we'll now have this. Remember, the first thing you do is to click, right? You click a button, right? Your left button. When you click it, it should take that will be your top left. Your top left, yes. Then as you are dragging, the top right keeps expanding. The top, that is where the X is. That's where you are. That's where your mouse is at the moment. That will be where your cursor is. That is where the is dragging. Right? We'll put an is dragging, which is to show us where our cursor is. And then we'll keep doing that. And when we finally let go of our mouse, right, that is where the X2, Y2 is, which is the bottom right. Right, so this is where you click, and this is where you click. This is where you do your clicking, and this is where you do your unclicking. And we have, with this, you can draw any rectangle you want to. Beautiful. So let's go back to our code. All right, so now we say cv2 dot set mouse callback, right? That's what happens when I click my mouse, right? So what are we going to send to that? We'll send the window name, and then we also right? Originally, what is the where is the mouse? We are going to see it just shortly. We're going to see it shortly. On mouse will be, this is the function which will tell us what the mouse will do when we click and so on. The mouse interaction, and this is the name of the window that we are sending to it. So that's that. We'll go down here. Let's just put it here. Um our function. But before we start our function, let's give so initialize. Right, we'll have first of all that our mouse position, right? Or I like calling is dragging. Where is the mouse position at the moment? The roaming position, which is originally unknown. Then another thing will be um, uh, another thing will now be where is our start x and our start y. So we have that start x. This is just an initialization, which will become a start y will be equal to 0, right? The top left, while this itself is the bottom right. Okay. Then another thing we'll check will be if the user has done selection or not. So at this point there's no frame, right? But this will change. Remember, this changed later somewhere here, right? So we can just say frame is equal to none for now. And then we'll have to check if the selection has been done. So selection is equal to none. This is just so that you can catch when selection has not been successfully done. All right, so let's check code our mouse interactions, our or what we call in Python our events. So def, remember we call it on mouse. That was the name we chose to it. Please, it's not a generic name. We just decided to choose it. You can call it whatever I want to call it. Just decided to call it on mouse to show what happens when I click my mouse. That's just me. So let me just put a pass here. I'll change it shortly. What is it going to take? First of all, it takes event, right? Then it takes the x position, mouse x position, the mouse y position, flags and user data. Please, you just need to add this, even though we will not really use it, just to make it complete. And we've run into a problem with this before when we drawing over a picture. We saw that we needed to add this just so it works, right? You can just put underscore, but whatever is the case, just put it. It does not harm, it does not hurt you to do it. Okay. All right, so now we'll make most of the things by using global. Please, you must not make it global. You can decide to just put it here, right? But let's say we'll make it global, so we keep using it because we keep calling the function from outside. So we have is dragging, so that once we change it, it's already changed. We have is dragging, we have start x, we have frame, and we have selection. Beautiful. Then if event is equal to cv dot, what if it is a late button, right? cv2 dot events late button down, right? Yes, when I click my late button, what is going to happen? My start x and my start y will not be at that position again. So my start x and my start y will now be m of x, that's where the movement of the mouse is, and m of y. Okay, beautiful. And then is dragging will no more be false, or will no more be none. Will now be true. All right, beautiful. Now, however, if event equals to cv 2 dots cv2 dots. Remember we have three. Then either our mouse is moving, we left click, or we click right. We click left, we are moving our mouse, or we click right. So what if you are moving our mouse? cv2 dot so same thing, events. No, mouse move. Right? If we are having a mouse move, what will happen? Right? If we are moving the mouse, but we have not clicked it, that means you're just moving the mouse all over the video. It does not do anything. No, we have to click and drag. So if you are just moving the mouse, so we need to check first if you have actually clicked it. So if you actually clicked it, that's you have to check if it's dragging. That's if that is dragging is true, right? If it's dragging is true, what we to do is that then at that point that will now be your the mount, the place that position at that point will be where you're going. That will be the bottom right at the moment. That's why we are calling it temp. So frame dot copy, right? That's just what you are going to show for the moment, right? And then cv2 dot rectangle, we just draw that to show that we keep drawing it at the new position of our mx and our my. So what do you all normally give to rectangle? The frame, which is in this case will be a temp, and of course the start x and the start y. The start x and the start y. What else do we give? The mx and the my, right? Then what else do we give? We give the color, right? Let's just keep it at 0 0 0 at first I'll change it along the way. Okay, then we have this as the thickness as 1. That's been done. Then we show cv2 dot show. So what you are showing is just the temp, and it will have the same window name so that whoever is using it will feel that it's the same window as what has been showing, but it's actually the temp window. It's not the frame that we showed before. Okay. All right. So that's the second one. Now the last one, elif event equal to cv2 dot event lay button up. See, right? So remember the first one was button down, now it's button up. What will happen is our selection will no longer be none, right? We've now had our 4 selections, which is start x, start y, that position now, which is our mx, our my, right? So these are the things we need at this moment now. So we return our is dragging back to false because we've gotten what we want, right? Once is dragging is false, then we'll now draw it on the rectangle. cv2 dot rectangle frame of course start x, start y, right? and then do a lot of things, mx and my, then 0 0 255, and of course this will be 1. All right, then we'll now add our text there, whatever text is. Once we've done that, we'll now we are now free to start the frame from the beginning to be checking. We start checking what is within that place, so we can say, but we want to show that we finished that phase test, so we'll just put it there. Please press here to continue, so that once the person makes a click, we know that we continue, and then it will start checking now, checking the video one by one. So the first one was just doing the setting, creating. That was for the user interface. Now the user has no other role again to play, but we don't just want it to start immediately. We just want it to the user to just press enter then, or press anything on the keyboard, then the thing can start monitoring. Beautiful. Okay, then we have cv2 dot put text. We use a lot of put text very well. We have a frame, we have press key to continue. All right, and then right at the top, if you want to put at the top, this is the location. Then the font, yeah, the font will be cv2 dot font share simplex. This is it, font share simplex. Then you have this as 1, then we have this as 25500, which is the color. Then you have this as that's my thickness 2. Right, the first one is the font size, this one is not in thickness 2, and then let's just put a line over it optionally. Line optionally. Stands my keyboard will just be crazy. That's fine. That has been done now, and cv2.intro Windows name, frame. All right, so that is that for the mouse interactions. Looks nice to me. I'm trying to check everything. Okay, looks good to me. Looks good. But if there's an error, we'll catch it probably when we run it. Okay, beautiful. So here we come to this point. The person has clicked the mouse, and then it's now running, and so on. It will keep running until it gets to the end of the day. So of course, let's just close it and do our normal so once you press something, right, once it sends a call back, right? So this 0 means the user has pressed the key. When it said that I should click here, right, to continue, press the key. That's why 0 is here. Any key at all, it will simply destroy that window and then start afresh again, but it has taken those points. cv2 dot destroy all windows. Okay, so that's the first stage which has been done. Now the next stage is when we now start our processing loop, right? a processing loop. So while true, it's now running the video, running over the video, running over the video, right? Which is basically our next step. What will happen is right. Remember it's still the same thing. We are going to pick that video again, right? With the first one was just the first frame, just get our bounding box. Now we are going to run the video from the beginning again, and then it will now do the operations we want to do. So this is now where the processing will happen. So if again it's basically the same thing. If not rate or frame is none, let's just break. We could either do the system thing or break. So let's just for now can add a system thing. Right. So now we've gotten the selections. Remember, we've gotten the selections is here. That's why we call them selections is here. You're wondering why we put it here when we have it. We didn't use selections here, right? We use this. That's because we want to hold this, right? Remember, it is what? It is global. Beautiful. So what do we do at that point? I want to check. I want to just do some housekeeping to be sure that because the human beings are selecting that they didn't select an x1 that is bigger than x2 and a y1 that is bigger than y2. If you understand what I mean, the top left should be smaller than the top right, right? It should not be bigger. So we are going to just do our home check just to check that's all. So okay, so x0 or y0 x1 y1 is equal to selection. So the next thing will our x min, y min, x max, y max, right? Will be minimum. What will be our x min? X min should be the minimum of. We're just normalizing. Should be the minimum of. You know that what you want is actually the minimum, right? It should be a minimum of x naught and x1, right? Okay. Then y min should be the minimum of y naught and y1, just to normalize it to show that it does not the wrong thing. Right, while the other ones are the maximum just the same thing, but just this k in this case it will be the maximum, the maximum. All right, that being done, we've finally we've successfully normalized it. So it's not such an important step, but it's an important step to say if we are actually looking at productive standardized coding, right? Just to close all the unusual loopholes. So now, what happens when we get our image in a frame? What do we do? There are some processing steps we take, right? I'm just going to show you the processing steps now. So there will be 5 major steps. The first one will be background subtraction, right? The background and the whatever is there, the foreground should be we know, oh, this is the background, so that once something new enters, it will be able to differentiate what has come in and what is in the background. Any other thing that was static is basically the background. Anything that is moving is the foreground. All right. Then the next thing is thresholding. The thresholding basically removes shadows. Right? Shadows, of course, you know that wherever there is movement, there's shadows, and wherever there are pictures, there's shadows. Wherever there's light, there's shadows. And shadows are easily to spot because they're always darker than the conventional background. So thresholding basically remove the shadows. Then we have eroding, we have dilating, and we have we now look for contours. Contours is basically looking for the edges. Now, what is eroding itself? Now, what does eroding do? Eroding shrinks white region. Remember that we are going to change our frame into binaries, right? Binaries has black and has white. So all the background will be black, while the white that you're seeing there will be the moving part. That's the part that it is going to capture, right? So erosion basically shrinks the white region, right? How does it do? It works by sliding a small matrix of about 10 by 10 across an image, right? So that when we have small boxes, like points, we know that that cannot be the image you are looking for. It has to be a large shadow. If somebody is entering, you can see a human being is entering. It's not going to be a small dot, right? Any small dot should be maybe something very inconsequential. So now that's why we keep it for this our project. We keep it at 10 by 10. Anything around 10 by 10 is removed, right? So it's basically for removing noise and small bumps. If you look at your black and white picture, you'll be seeing some small white things there, which is not what you actually want. So those thin and small white areas will basically disappear. So the next thing is the dilation. Dilation is the opposite of erosion. Dilation expands on white regions, right? So the same kernel will slide across the image so that a pixel becomes white, right? Any other pixel, right? It's white. Such a case is more like it's undoing, it's brushing up what erosion must have done, right? It's just brushing up what erosion must have done. So let me just give a brief summary. So what erosion does is that it shrinks white areas, remove noise and isolate objects. Dilation on the other hand expands white areas. It's more like restore shapes and fills in the gap that erosion must have missed. So erosion again smooths edges, moving small noise, right? Cleans the noise, while dilation basically does restoration. And that's the difference between them. And then we now have contouring. Contouring is more like you're looking for the edge because it is that edge that will be able to draw bounding box, right? So now it's well, this is just basically what I said. Erosion is used. You use a kernel for it, so it's more like a stencil and a brush. You sweep over the image. So if it's a larger one, we are going to use 10 by 10 kernel. If you have a larger kernel, that means you are using a bigger brush, right? It's going to take a bigger chunk, right? Even though it will be smaller, it will be more aggressive and may basically remove good features, right? While smaller brushes, maybe 5 by 5 kernel, smaller kernels, right? It gives finer details, right? You are going to see the morphological kernel in our code right now. That's what we use for erosion and dilation. It uses the kernel, morphological kernel. All right. So now, why do we need to do contouring? When we apply, of course, our subtraction and thresholding, we have a mask. Remember, I said we have black and white mask where the white part is what we want and the black part is the background. Now, white areas, of course, moving object black is the background. Now, contours are simply those backgrounds around those white blocks. So, what happens when you are looking for once you find contours? You can identify where the movement is happening, measure how big each moving region is, and also draw bounding box or labels around those moving objects. So, it's just as simple as that. So, let's go back to our code. Right. So, before we start, we are going to put some some setup for morphological subtraction. So first of all, our kernel, we've talked about kernel shortly, which will be 10 by 10 NumPy the ones. Right. So let's just tell you what kind of unit it is. So you have the np.98. Then our background subtractor, right? What kind of background subtractor are we going to use? So should I put, yeah, correct. Since it's spelling of subtractor, we are going to see the two dots. There are so many of them, but we'll use the basic one. Create background subtractor. We have KNN, and we have nearest neighbors, and we also have emoji. So we just use emoji too, and then so we are going to have the text shadows. Yes, we want to take shadows. Remember, I said it's going to do that. Then and yes, true. Then variable thresholding, put at 50. Remember, I said we'll do thresholding. Then there's something something else we call history. How many times do we do it? 1800. Okay, so that being done. Now the next thing will be contouring. What is the minimum area for us to consider it a detection? We want it to be large so that it will be as if it is a human being, because there are some things that your erosion and dilation may miss. So minimum contour area for which to see it is a detection. So let's just say 1500. Okay, so now we have to set parameters for our erosion and our dilation. So we have erode iteration. How many times do I want to carry the one? Then let's just keep this as 2. Okay, beautiful. So these are basically constants that we have. So I'll just call this morphological constants. Okay, great. So that being done, we can now carry out the main task that the main morphological task that we have to do, the main processing. So first of all is we want to crop out the area of interest. Everything we'll be doing will just be in the area of interest. Everything will be in the area of interest. Any movement that's happening outside the area of interest, we are not interested in it. So the region of interest will be frame. Just crop that side out. So just use our normal slicing, which will be our y min. Remember, we already set our y min to y max, right? And then we have x min to x max. Oh, I didn't have this. Interesting. Okay, so it's just the sliding. So let's just copy this to be safe. All right, in case we need to changes along the way. So now the foreground mask, which is we have to apply subtraction first. So where do I apply to the arrow eye, please, not the entire frame. Okay. And then the next thing we do is remove shadows thresholding. So this AG mask, right, is going to tell you true or false. So we don't need the first thing. The first one here will be equal to CV2 dot threshold. All right. So that has been done now. Now the next thing is we'll do morphological morphological steps. That's our eroding our dilation. So we have that AG mask. So go to CV2 dot erode AG mask. Right. We have to put the kernel for us to know. Then iterations. How many iterations are we doing? I think we set this as 1 and the other one as 2. So just call it erode iterates. Then this is basically almost the same thing. The dilation will always be the same thing, but in this case we are looking at dilate. So this iteration is will now be dilate iteration. All right. So the final step will be our contouring. I don't know if I've done something on contour. We've not done a task on contouring before. It's normally used for. We normally use contouring to if you want to cartoonize an image. You know, when you're looking at cartoons more like takes the edges and then gives it another different color. So that's basically contouring is very important when you're doing when you're cartoonizing an image. All right. So we have CV2 dot find contours. Let's find the edges. It's same way of saying find the edges. Find contours, and then of course we put our AG marks here. Our AG mask here we have CV2 dot CV2 dot right, the method we are going to use. So this is how you find our contours. So now that I've done in these steps, we may find contour, you may not find, right? No, it's not all the frames that will have movement. So if we add contours, what do? We get the largest. The largest among those that there may be several moving objects. We get the largest among those that meet a particular threshold. So we have that the key will be our CV2 dot contour area. We had already set the area we want. Okay. If CV2 dot contour area, the largest, right, is greater than it's crazy that I'm looking for greater than on my keyboard. All right, at least I found it. Says if it is greater than minimum contour area, the minimum contour area, right? We've already said this. Remember, we said that as 1500, if I could remember. If that is the case, then these are the bounding blocks of the once we will have it will give us the top left, right? And it's the top left x, the top left y. That's the top left x, the top left y. Then to give us the height and the width. So with that, we can use it to get the bottom. Of course, get that right. And once you have the top left, and then we have the height and the width of the box, we are good to go. So the next one is ry, rw, rh, which will be equal to cv2 dot bounding rect. Just great. So just that this may just be an image, but it must not definitely be a box. So this is going to give the bounding rectangle around that box. Beautiful. So that's that. We will now draw our rectangle. This particular rectangle now, we will now draw it on the image or on that ROI. So we have CV2 dot rectangle. First of all, with a frame, which in this case are ROI. Then our starting point, which is x, rx, ry. Then we now have our rx plus width, right? Then we now have our ry plus h. Then we have the color, which is 0, just be consistent, 255. And then we have the width too. Then we now have to put a text, just the way we've been doing, and the person has been detected, or intruder detected, anyone you wish to, with 2 dots. Put text, ROI, intruder detected. We have RX, we have RY. So let's just make it, we'll just keep it there. Let's keep it there. I wanted to add something to it, just pad it a bit. I like doing that. Then where am I going to put it? That's a bit up, not at the same, up on top of the box. That's why you're seeing me calling it padding and padding it up, so it will be on top of our detection. All right. So what will be the font? CV2 dot font. Font is a simplex. Font H is simplex. I really find this font, I've seen it to be interesting. 0.6. Color is 0, consist 0, green 255 0. If the other one is that color, this should be another color. Yeah. Then 2. Then let's just put a line on it. CV2 dots line AA. I hope everything is in order. Yes. All right. At that point, we will now place this frame that we've edited back. Remember, we just work on the ROI, so we just place that ROI back on the main image itself. right? So frame, we replace it. So we have that frame, the original frame. This, right, will now be what? It will now be ROI. Just simply go and replace it there to just fit back. Okay, that's been done. So we'll just simply, now that we've done that, we'll just show our image. CV2.image show. What did we call it? Security system. Alright, and then we have this as our frame. Alright, our security system and our frame. And then so this is just that. Housekeeping, what if the person wants to end it or it finishes? So there are two things, either the person ends the video or it finishes. Most times when we are ending, you press Q, it will end. We've been doing that every time. Or it just goes to the end, right? So if CV2 dot wait key, we want to check, sometimes you can use 1 second, but let's just 1 millisecond, but let's just make it 30. It will be checking every 30 because the videos can be grumpy sometimes, and you should be used to this already. All right. Order. Okay. Right. So to break, you press key break. Right. Then cap dot. Okay. So this is the entire code. I'm seeing an error somewhere, trying to picture where it is. So this is an error. Why should this be an error? Okay, there's a comma missing here. Okay, so with that, I think we can run it and then see what we are going to get. So let me just run this. Okay, it's saying CV2 has no attribute wait key. That should be the first one. The first one that's this is it. So let's run this again. So here it says cannot access local variable start y. That's because we made this global, we didn't make start y global. So let's just also make start y global. So start y, make it global. Interesting. So let's just run this now. See if it's going to work. Hopefully it works this time. Yeah. So this is our ROI. Oh, this is a big grumpy. Work on it. Press any key to continue. So for now, just press a key and see. So there's nobody in this room for now. See somebody coming. The wait can be crazy. I hope somebody comes in. Yeah, I think the door is moving. Someone is coming. Oh, it's caught the intruder. Who is this intruder? Oh, there's an intruder here. Okay, beautiful. So it has gotten to the end of the video. So that's basically the entire project, and it work on longer videos too. So okay. So there's something we wanted to work on. It was just basically the have press key here to continue. It seems this was a bit too high. Um, Probably will make it 0.5. Right. And we'll make it black too. And then run it. So yeah, press any key to continue. This is better. That was too big. All right. So with this, to make the detection, so I will not really need to do this again. So that's everything about the video. I hope you understood every part of the video. If there's a part you don't understand, or there's something you feel I must not have said right, we learn every day. So just put it on the comments, and I really appreciate if you do that. Please don't forget to like this video and also share the video. I'll put a link to my GitHub page. You can check um, the full code there if you cannot really see it here. And thank you very much, and we'll see you in our next video. Don't fail to come back.